let's get on with this. So, alright, DHCP version 4. We'll have a look at how it works, how to set it up as a server on a router, and how to configure it as a client, as in the router as a client. So there's a bit to cover, and the good thing is it'll be with command structures today. So after today's theory, you can go off and do some labs in Packet Tracer and actually put this into practice. So within Packet Tracer, you can set up a router as a DHCP and then add some PCs into the topology to get their IP addresses from the router inside Packet Tracer, and that will help cement all this theory together. So this is where we spend roughly about the same amount of time in theory as we do in practical labs now. So if we were doing face-to-face classes, which senior management still hasn't approved my travel permit, we'll talk about that later. Let's get on with this one. Alright, server and client. So we all have by now got the concept of how DHCP works. It's a pool of addresses that can be assigned to devices as they join the network, and this is defined by the administrative team, and we set it up so that we save time not having to individually address every machine on the network. They are very easy to set up and configure and maintain, and quite often in a small network design we will use routers to do this because it's quick and easy to set up and maintain. We don't have to actually have a dedicated server doing this, as well as file management and things like that. So quite often in small business you'll find this type of scenario. So we get to assign addresses automatically from the router, pretty much like you do at home. You define the pool, define how long the lease is going to be, and as they join, they go through the joining scenario, which we'll talk about how that all works. So when a device gets a lease, it maintains that IP address until the end of the lease, and that lease, once it is expired, the device has to reapply for a new IP address. Now this is typically just automatically reassign the same address, but occasionally it can actually change the IP address on renewal, depending on what's going on. Okay, so this allows us to reuse IP addresses, so we can basically oversubscribe a network if we have a large mobile workforce, such as the sales team and things like that come and go regularly throughout the day. We can very easily oversubscribe. In other words, we'll have a smaller pool than actual workers, on the expectation that they're not in the office needing those IP addresses consistently. So there's always ways of managing this. Okay, so the steps for the obtaining of an IP address, we'll just quickly go over again. So the client comes online and it sends out a DHCP discover broadcast, and any server will pick up that broadcast they will send a DHCP offer, which is a unicast back to that client with their MAC address. And then generally it will be the first offer that they receive. The client will send out a request and the server will acknowledge that request, saying, yes, you can use that lease and here's all the final details. Basically, that's what the acknowledgement is saying. So in the request, we basically send a message that has the information that was in the original offer from the server. Now, if there's more than one potential DHCP server out there, you're basically telling all the servers this is the IP address you're going to go with, and that server will respond with the acknowledgement. So in this scenario, we'll basically look at it as the topology there, the router serving two networks, being the 192.168.10 and the 192.168.11 networks. So we can set up a server which is on the 11 network, and this server could, if you wanted to, serve both networks, or it could do what's called a helper and pass those broadcasts for the requests and discover across to the server, if that DNS server was also a DHCP server, for example. So there's many ways we can do this, but in this example here, we're just going to make the router our DHCP server for both our networks. Okay, so we can assign IP addresses to both the 10 and 11 devices. So what you tend to do is exclude any of the address ranges that you don't want the pool to give out to devices such as your servers, your printers, anything you're going to statically assign addresses to, you tend to want to have in the excluded range. And the command to do this is IP DHCP excluded dash address, the lowest IP address that you want to start the exclusion from, to the highest address in the range that you don't want to assign out. Now, cast your mind back to when we did IP address design. We basically said we have devices, in the low network range where we had intermediate devices such as routers and switches, and then our servers, our printers, and all that. And then we had a whole larger pool that was assigned to clients, and these were all in consecutive batches. The reason we do that and make those addresses like that is because these tools can use these exclusion ranges to automate that for us much easier. Each pool needs a pool name. This identifies all of the parameters under the one config, because you can have more than one pool on the same device. So when you start actually putting your commands together, when you start it off, you do IP DHCP pool and then the name of the pool, and this will change your prompt to the DHCP config prompt as displayed on this slide. Now all your commands that come in underneath here are going to be associated with that pool. So we now need to define our network address ranges that we want to assign within the pool. So network, the network number, and the prefix links or the mask, so that the device knows what network it is serving and assigning addresses for. Default router is our gateway address that gets pushed out to the hosts, then DNS server and the address. Now, if you put multiple addresses, you can have up to 8 addresses, and this would be if you can't contact the first one, move to the second, move to the third type scenario. Domain name. So if you are a member of a domain, it will push out the domain name that your device is a member of. You then have to define how long your lease period is going to be, and this is defined in days, hours, or minutes. And if you don't define it, it'll have a default value, and you can make it infinite. Not recommended, but you can do it. Next, you have your NetBIOS Win server. There's still some legacy devices that need this running, so you may need to put that in there. So what does this look like in our command structure? IP DHCP exclude address 10.1 to 10.9, so it's not going to assign the first 9 IP addresses. We then have a second line saying don't assign .254. So we're blocking 10 addresses from being assigned out of the pool. We then create LAN pool 1, and we tell it that the network is the 192.168.10 network with a /24 mask. The default router, so this is the IP address on the router's interface for that network, 10.1. We tell it where the DNS server is, which is over on the 11.5 network. And you're going, that's a wrong? Yes, it is a wrong. Because the DNS server, according to the topology map there, is 11.6. So we would never see our DNS. No, they're not. What will happen, Jacob, is if an address is already assigned, the servers send out messages all the time. And what they do is they discover, basically using like the ARP, right? They discover all your devices on your network and what addresses that they're currently using. And they make a note of what addresses have already been assigned. And this is a safety feature, so it doesn't reassign an address already in use. Okay, so yes, you don't have to exclude any addresses in a pool. It will discover them, but it's best practice to exclude them so that it doesn't cause any issues if something goes wrong with the auto discovery feature of what's already assigned. Okay, so it's best practice that we exclude them, but there is a safety feature within the protocol to actually self-discover addresses that have been assigned, either static or dynamically. So, so that DNS server address should be 11.6 according to the topology diagram, not 11.5. Domain name is example.com, and we then end and save our configuration. Rinse and repeat for the 11 network so that they get their addresses assigned as well. Confirmation commands as show running config, and the section we're looking for is DHCP. A show IP DHCP binding on the router will display all the MAC addresses to their IP addresses that have been assigned, and the show IP DHCP service statistics gives us all the information regarding the messages that are being sent and received via the server. So let's have a look at the output of these commands. So this is where we use the pipe symbol and use the section option to restrict the running config to display us a cut down version of the running config command. It's good practice to use these types of commands. Section begin can help you not have to page through pages and pages of running config, because as your network gets bigger, your running configs can be huge. Okay, so it's not always going to be a quick, easy solution just to do show running config. It may be better to do a section command or a bin command so that you can cut down the display. So on the show IP DHCP bindings, here we are. This is the IP address that's been assigned. This is the MAC address of the device that it's been assigned to. This is when the lease expires on this device, how it was assigned, whether it was automatically assigned, it's active, in other words, it's a valid address, and the interface that the address is assigned via. So it's saying the 192.168.10 network is being assigned via Ethernet 000. And here's our statistics command output. So here we have the number of pools. As I said, you can have multiple pools serving different elements. One of the networks that I managed years ago, we had printers coming in and going out of the office. We had a very fluid office environment as far as staffing and resources go, because some of the times the printers and that went from the office into the classroom to do bulk printouts for the class and that sort of stuff. So we would put multiple pools in there, and you can do a static assigning, so you can actually specify the MAC address of the device and fix the IP address as a separate pool, so that every time that device came back into the network, it was assigned the same IP address. It's one way we can keep our printers and that on the same IP addresses and still have them served by DHCP, just as a quirk. It's one way of doing it. Automatic bindings, so this is where the addresses are assigned out. Manual static assignments, how many renew messages, secure ARP entries, you can read the list. So down the bottom is the main ones we tend to look at, which is how many discover requests have been sent and received. So these are our request, decline, release, and inform message types. So we know how many are coming and going from the server. So on the device, our IP config/all will give us all of the information that has been assigned to the client. So there's our DNS suffix, there's our IP address, our subnet mask, when the lease was obtained, when it will expire, what the default gateway is, where the server is, and where the DNS server is as per our configuration. And as you saw in the topology diagram, we wouldn't be getting any DNS service because we've configured the wrong address. As with all the other commands in Cisco Land, you put no in front of it, so no service DHCP will disable the DHCP globally on your router. Basically, it's good practice if you're not using a service to shut down the service. This allows you to have confidence that there will be no exploitation of that service on that device. Okay, so if you shut down the service, it can't be exploited. Many services are on by default. It's up to us to know which ones are on and whether we're using them. If we're not using them, we should shut them down for security. The relay command. This is very useful if we actually are running our DNS server suddenly transported to 11.5 and our new DHCP server is at 11.6. Okay, so what happens is the discover message is a broadcast. So when PC1 sends out that discover broadcast, it'll go up to the router 1 and go, yeah, no, that's it, done. So it would never get over here to the DHCP server. We can use what is known as a relay command. And what this does is it provides for DHCP, DNS, TFTP, FTP servers, and a couple others to be automatically redirected to a IP address. So we would configure this device saying I've got an IP relay pointing at 11.6, and when PC1 sends out its discovery protocol going, I want an IP address, this device, if it's got a relay configured, will then forward it to the server configured as the relay. So the command to do this is IP helper address, and you configure it on the interface that you want to forward traffic from. So if we go back one here, G000 is where the traffic is going to come in. So PC1 sending that discover broadcast comes in on interface G000. We have an IP helper address configured on that interface. So it will now forward that broadcast to that server on behalf of PC1. So it becomes a relay for the servers. So the server will now respond to router 1. Router 1 will then convert that message out for PC1 and back and forth, and the DHCP service will act as if it is normal. So, as I said, we have a lot of different services that are part of the relay process. So our time, TACAX, DNS, DHCP, TFTP, NetBIOS will all be part of that IP helper address forwarding. Alright, so you can see there's a few different broadcasts that IP helper address will forward on behalf of the clients. Okay, so coming up we have how do we configure our server as a client. Well, we do this pretty much all the time when we connect small businesses up. Okay, so the ISP will send out its little message saying this is your IP address. Okay, so we can either statically assign that address on that interface, which is 9 times out of 10 the way it's done. But some of the smaller ISPs will rotate their addresses just like they do in a normal enterprise. So you need to be able to set up your DHCP client as your router on that interface to accept that DHCP configuration. So that interface needs to send out the request and the discover messages to get the IP address assigned. So it's a very simple command. We go to the interface, we go IP address DHCP, no shutdown. So this turns the interface on and we're telling it that its IP address will be assigned to it via the DHCP service. Pretty straightforward. And after it gets an IP address, so the first thing it's going to do on startup is send that discover message out, and once it gets it all coming back in, there it is. It's got its internet address, it's got its subnet mask, and the address is determined via DHCP. So the output's a little different for the show IP interface as what it would be if it was statically assigned. So if you did what Cisco would love you to do and buy a Cisco home router, otherwise known as the Linksys router, you'll be familiar with this type of interface. So under the setup, we just go in internet connection type, auto configuration DHCP. That's the equivalent of that command. Job's done. So as a reminder, please complete the packet tracer activities for this chapter. You'll go through setting up DHCP pools, and it'll help you understand the function of the IP helper address and the pool commands. So here we have a method We've covered this in multiple times, so you know all about how DHCP works. So I'll just do a very quick summary here. So DHCP is used to assign IP addresses to clients as they boot it up. We have a pool of addresses that we assign from. They also push out additional information such as gateway, DNS server. So you configure the core requirements of every client, which is an IP address, subnet mask, default gateway. That's the three things that need to be pushed. You can then push out optional things like DNS server, where TFTP servers are for voice, for example, and other items. We then went through the discover, offer, request, and acknowledgement sequence, and how those messages are used to generate the lease. And we looked at how you can configure a Cisco router to be a DHCP server. And we also looked at the scenario where we can use the router to be a relay point for multiple protocols to a server on a different network. We looked at how to shut down the service so that if we're not using the router as a DHCP server, we can shut down the service so the service cannot be exploited. The IP helper address supports multiple protocols, and we looked at the ability to configure an interface to receive DHCP configuration for those remote connections that we act as a client from our ISP perspective. Instead of using a static IP address, if we're using a dynamically assigned, such as our home routers do all the time, if we've actually got a higher level router than the common home device, we can actually configure the interface to accept DHCP configuration and connect to our ISP. And that brings us to the end of Chapter 7. Hit the stop.